In today's lecture, we are going to see how binary number is converted into gray code converter and circuit will be designed for the same. All of you know in previous lecture we have seen in detail how binary number is converted into gray code converter. So all of you know binary numbers. So here numbers are taken from decimal number 0 to decimal number 15. So binary equivalent number for 0 to 15 is written over here. 0000 is the binary equivalent of 0 and like this. So this chart shows binary number and equivalent gray code is generated over here. So for 0000 gray code will be generated 00. So what is the actual process to convert binary number into gray code, that I will explain with by taking the example, single example. Suppose the number is 0010. The number is 0010 and how its gray code is converted. So all of you know what is the procedure. Keep first digit as it is, then add first two digits, that is 0 plus 0, we are getting here 0. Add second two digit, that is 0 plus 1, we are getting 1 here, and again add 1 plus 0, so we are getting here 1. So by gray code equivalent of 0010 binary number is 0011. So we can verify here. So number is 0010 and its gray code is 0011. So 0011 like this. So same logic will be here. What is the logic? Keep first number as it is, then add first number into second number, then next add second number into third number, and lastly add third number into the last number. So this is the gray code equivalent of binary number. So this chart shows binary number and its equivalent gray code converter. Now we have to draw the K-map for gray code converter G3, G2, G1 and G0. Actually what we have to do, you have to implement the circuit and you have to apply the binary number to the circuit, and automatically output is the gray code that will be generated by the circuit. So we have to draw the circuit, or you have to design the circuit. So for this is the first process. Block diagram: input is binary, output is gray code, then truth table which shows binary number and gray code converter. Now for this first, so what I said, first digit as it is. So first digit as means B3 and G3 is totally same. So first digit is B3 and here also first digit is G3. So G3 will be same. So B3 is equal to G3. But from K-map we can generate B3 is equal to G3 like this. So first 8 numbers are 0. So 0 0 0 0 0 0 0 0 and 0 0 0 0. Lastly 1 1 1 1 and lastly 1 1 1 1 like this. So how group will form? So group will be formed by 8 elements. So what is the expression here? So G3 is equal to, expression is, what is the common? Common is this 1 1. So 1 1 is common and 1 1 for B3. So G3 is equal to B3. So this is the equivalent expression for the G3. G3 is equal to B3. Again for G2, table shows 4 times 1, 4 times 0, 4 times 1, 8 times 1 and 4 times 0. So same will be as 4 times 1, 8 times 1 and 0. So group will be formed like this. Group will be like this. And its expression is G2 is equal to, for this common element is B3 bar B2. So I will write here B3 bar B2 plus for this B3 B2 bar. It means it is the XORing of B3 and B2. In short, we can say G2 is equal to B3 XOR B2 like this. Again for the G1, you can draw the logic expression. So G1 is equal to G1 XOR G2. Again for G0 is equal to B0 B0 XOR B1. So by K-map realization, you can form the group, and by forming the group, everyone knows how expression will be generated. So from this binary to gray converter, 4 equations are generated, and that 4 equations are like this: G3 is equal to B3, G2 is equal to B2 XOR B3, G1 is equal to B1 XOR B2, G0 is equal to B0 XOR B1. And from this you can able to draw the block diagram. 4 inputs B3, B2, B1, B0. XOR gates are used. So here G3 for B3, then for G2, and then for G1, and then for G0. So these are the 4 outputs and these are the 4 inputs. So in this way you can draw binary to gray code converter, and question will be asked for 4 marks or 8 marks, because lengthy question is there, so that's why it will be asked for 6 marks or 8 marks. So what you have to draw the block diagram. Simple block diagram is there, binary to gray converter. So number of inputs, 4 inputs are there, 1 2 3 4. Number of outputs, 4 outputs are there here, b1 b0 b1 b2 and b3. Here G0, G1, G2 and G3. So this is simple block diagram. After that, truth table. After truth table, logic diagram, logic expression, and lastly this is the uh, logic diagram.